Welcome to this eLearn Security video on exploiting blind SQL injections. When an application is vulnerable to SQL injections, but it cannot be exploited via in-band or error-based injections, penetration testers can still inject queries and get the result back in terms of true-false conditions. In this video, we will use differences in the web application output to tell if the condition evaluates true or false. We are going to study the artist details page of the Montville Recording Studio website. After visiting the Artists page, we can click on the artist's logo and access an under construction page about the band and their work with the studio. If we change the band get parameter with a name which doesn't exist, the application just prints, "We did not work with them yet." Note that the behavior is the same if we inject some SQL special characters after a valid band name. To find tests for SQL injections, let's try a classic Boolean-based detection phase. A true condition is the offspring, apostrophe, space, and space, single quote A, single quote, equals, single quote A. While a false condition is single quote A, single quote, equals, single quote B. As you can see, we can tell a true condition from a false condition by looking at the web application output. We can use this behavior to extract information about the database and its content. Let's start our exploitation by extracting the database version. We can use the @version special field together with the substring function to extract the version string one character at a time. Our first payload is the space offspring, apostrophe, space, and space substring, parentheses, @version, comma 1, parentheses, equals, single quote 0. The first character isn't a 0. Let's increment the character until we find the correct one. The first character of the version string is a 5. Extracting a string by manually entering in the address bar different character values would take hours to extract the results of a simple query. So we at eLearn Security wrote a simple shell script to automate this task. blind1.sh iteratively tests the output of the payload we just injected by hand. Let's see it in details. The first line sets the characters we want to test. In this case, numbers, letters, and some symbols. Please note that the symbols are escaped with a backslash to prevent the shell from interpreting them. Then we declare the URL to attack, and the string to look in the output page to tell a true condition from a false result. The script is really simple. It cycles over the char set and submits our hard-coded payload to the web application. It filters the output looking for the true condition string and stops when the right character is found. Note that we hard-coded the payload in the script. It's the same that we submitted by hand via the browser address bar. Let's run it. The first character of the version string is indeed 5. To find the second character, we have to increment the position argument of the substring function. And run it again. The second character is a dot. Using this script in a full exploitation scenario seems to still be somewhat cumbersome, isn't it? Because of that, we wrote another script which accepts the maximum length of the string to test on the command line and then cycles on all the characters of the result. Here we set the maximum length of the string we want to extract. And here we run two nested for loops. The external one sets the current character to test, from the first to the maximum value we set on the command line. The internal one is the very same piece of code we wrote for blind1.sh that uses the j variable to identify the current character to extract. Let's test it. If we expect the version string to be up to 20 characters long, we can call the script by passing it 20 as command line parameter. As you can see, it extracted the full version string in just a few seconds. We can use this technique to find almost anything. We have to just replace the @@ version string in the script with a new valid query. Note that the query must return a single result, no more. To test more payloads, we could manually edit blind2.sh at every new query, or we can improve the script to accept the query on the command line. And automatically submit it. Note how we enclose the injected query with parentheses to make sure it will work with the substring function. Since the database version we extracted before tells us that the DBMS is a MySQL incarnation, we can use some MySQL functions in our payloads. Let's start by extracting the current username by exploiting the user function. We pass to blind3.sh 20 as the maximum expected length of the output and select user parentheses as query. Note that we enclose the query with double quotes to prevent the shell from interpreting user as a function. The username is montville@localhost. We can go on and check the current database by using the database function. The current database name is Montville. Now that we know the current database name, we can use the Pentest Monkey MySQL Injection cheat sheet to get some MySQL specific payloads. We start from the list tables query. We will need to customize it to make it work with our script. We copy part of the list tables query and then modify it to select just the table name field. Only for tables belonging to the Montville database. Moreover, we have to limit the results to just the first record by using the limit statement. The first table is accounts. We update the limit clause to display the second table name. Albums, and we keep going until we extract all the tables. After knowing the table names, we can extract information about the columns. We can start from the accounts table by updating our payload to select the column name from the information schema.columns. Where the table's name is accounts. As usual, we limit the query to the first result. The first column name is username. The second is password. The third is IBAN. And the fourth is secret question. Incrementing the limit clause value gives us no results, so there aren't other columns in the accounts table. At this point, we know that the Mottville database contains, among others, a table called accounts. Moreover, we know that 2 columns of that table are username and password. We can use this information to create a payload which lets us extract the web application's username and password pairs. Unfortunately, blind SQL injections let us only extract single values, such as the current username or a column name. We can get around that by using the MySQL concat function. The concat function returns a concatenation of its arguments. So our query will be select concat, parentheses, username, comma, space, single quote, dash, 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 single quote, comma, space, password, parentheses, space, from, space, accounts, space, limit, space, 0, 1. As you can see, we extracted the admin username and password pair. We can test it by copying the password, and using it to log into the website. The credentials work. Blind SQL injections are a great resource to extract data from a database. As you saw in the video, extracting even a simple string needs a multitude of payloads. Submitting many payloads means performing a noisy and easy-to-detect attack. Keep this in mind when exploiting this kind of vulnerability. Anyway, you can exploit blind SQL injections to extract any information from the database and execute any query you want. For example, you could use them to automatically set the length of a query output and further improve the script we saw today. In the next videos, you will see SQL Map, a tool that uses this technique and others to automate SQL injection exploitation. And this concludes our video on exploiting blind SQL injections. Thanks very much for joining us.